So cool. Okay, so this is the first session on DP on trees, right? So I've already told you that the foundation of DP is actually recursion, because if you can do a question via recursion and it has states, then you can save them, and you can basically use DP over that. But when you're specifically talking about trees, then this fundamental actually gets more emphasized, because in trees we can easily do a traversal using DFS, or we can simply say a recursion based on a traversal based on recursion, right? And hence when we're trying to apply DP on trees, then recursion is one of the most fundamental concepts that we are going to use. So in this particular session, we'll be talking of two questions from tree algorithms. We'll be solving the questions subordinates and tree matching. Now, these two questions are not based on tree rerouting per se, but in order to understand tree rerouting, as you guys were like requesting me for a video on tree rerouting, but these concepts are very fundamental if you want to understand such concepts, right? So before you go for tree routing, let's try to understand these concepts, and it would be better if I explain you the concepts in the form of questions itself. So that's what we are gonna do, and also it's cses problems. I'll share the link as well. So the benefit is that the problem statement is pretty small and it's not going to consume much of our time. Cool. So, and other than that, if anyone has a doubt within the session, he can speak right away. Cool. So the problem states that given the structure of a company, your task is to calculate for each employee the number of their subordinates. So then this is the input would be given like the first input line is an integer n, which is the number of employees, and the employees are numbered from 1 to n, right? And the employee one is generally the director, is the general director of the company. So the first employee would be the director of the company, so he won't be reporting to anyone, right? After this, we would be provided with n minus 1 integers. So over here n was 5, so we are provided with 4 integers. That would basically tell us that what this particular person reports to. So we'll say that okay, the person 2, so we are starting with the person 2 itself, because about person 1 we already know that he's the director, right? So person 2 responds to person 1, person 3 responds to person 1, then person 4 responds to person 2, and person 5 responds to person 3. So this is what we know. Now what do we have to print? So we have to tell them that to like a particular person has how many subordinates. So the number of the subordinates is something we have to print, but we have to print that for all of the people, right? So we'll be telling that okay, if person 1 has 4 subordinates, person 2 has 1 subordinate, person 3 has 1 subordinate, and then 4 and 5 only have 0 subordinates. So let's try to draw this. If you feel we are going a bit slow, then just hang on for a minute, because I just wanted to explain this in entirety so that no one feels left out. So this is the person 1, then person 2 is reporting to him, person 3 is reporting to him, person 4 is reporting to him, person 5 is reporting to 3. Cool enough. So this is the tree we are having. So over here, person 1 would say that okay, I have 4 reportees or 4 subordinates. 2 is going to say that I have 1 subordinate, 3 is going to say I have 1 subordinate, he has 0 subordinates, he also has 0 subordinate, right? So our resulting array would be 4, 1, 1, 0, 0. This needs to be printed, right? Now since in this particular question they have already said that the person 1 is the general director, right, or the general manager, whatever we want to call him. So we can see we can visualize this particular problem in terms of a rooted tree which is rooted at 1, right? So this is not an unrooted tree, rather it's a rooted tree itself, right? So we can say that we are going to start from 1. We are going to check for all the neighbors it has, right? And then we are going to ask that okay, how many, okay, so I'm going to ask 2 that how many subordinates do you have? So 2 is going to say that I have 1 subordinate, 3 is going to say I have 1 subordinate, right? Then it will say that okay, 2 is returning that he has 1 subordinate, so automatically the subordinate of 2 is also my subordinate, so 1 would be coming from there, but 2 is also subordinate, right? So I'll add 1 to that, I'll fix that into my score. So 1 would say that okay, 2 I'll have 2 subordinates from this subtree right over here, right? Then I'll go to this particular subtree, let's draw it with a different color. So in this particular subtree it will say that okay, how many subordinates do you have? So it will ask 3 the same question. 3 would say that I have 1 subordinate, right? So it will say that okay, since your subordinate would be my subordinate too, and you also are my subordinate, so I'll add 1 plus 1 to my final answer. So 2 from here and 2 from here gets added, right? So 1 prints 4. So 1 says that okay, I have 4 subordinates in total. But wait a second. What actually happened over here was when I was asking 2 that how many subordinates you are having. So it already calculated the number of subordinates it has, right? So it wouldn't make sense for it to calculate it again because he already knows that how many subordinates do I have. Now how would 2 calculate the number of subordinates it has, right? So that's another question. What it'll do is that it'll ask the node that's connected to it. So it'll ask for that how many subordinates do you have. 4 would say that I don't have any subordinates. So 4 would say 0, right? So in this process, the subordinates of 4 also got calculated. So 4 would return a 0. It will say that, okay, since you don't have any subordinates, but you are yourself are my subordinate, hence I only have one subordinate in total. The same would apply over here and the same would apply over here. Cool, that makes sense. Any doubts so far? Guys, any doubts or all good?
No, sir.
Okay, cool.
No, sir. Clear.
Cool, so let's look at the solution also. Okay, great. They tend to erase the solutions. Okay, and never mind. I'll just open the solution right from here. Okay, that's fair. Okay, so what we are gonna do is that we are gonna make a simple DFS call, right? And we are always gonna start at 0. Now they had said 1. They had said 1 because, but we are computer science engineers. We are gonna go with 0-based indexing. So over here, I've already subtracted 1, right? So every time I'll be taking the input, I'll be subtracting 1 from it. Cool. So that we are talking about the 0-based indexing. So basically by this I'm doing 0-based indexing. You can also go with 1-based indexing in case you want that. But I was going with 0-based indexing over here. Then I call the DFS traversal for the root itself, right? And I have also declared, you can call it a DP array. I've called it a result array. So my result array actually stores the number of subordinates you have, right? Then I'll call the DFS for all of its children. So if you remember the graph over here, so if you remember this graph, then 1 would call for 2 and 3. So 1 would ask that how many subordinates do you have and how many subordinates do you have, right? So that is going to happen over here, right? After that, I'll add all the values that my subordinates are getting me, right? So once that is done, after that I'll return it. But when I'll be returning it, I'll be adding 1. Now why is this the case? Why am I adding 1 over here? Now the reason to add 1 over here is because this particular result I'll be returning to my parent, right? So my parent knows that I actually, so what do I mean by that?
Zoom the code little bit.
Okay, cool. Thanks, bro. Okay, is it fine now? Can I unzoom it a bit? Abhi, is this fine?
Yes, good.
Okay,
Can't say that.
yeah, cool. Okay, so what actually is happening over here is that I'm asking my child process, or I'm asking the subordinate to tell me how many subordinates do you have. So one thing you can actually do over here is you can say 1 plus DFS and you can print result over here directly. That should also work. Okay, so your subordinate would return you that, okay, these are the number of subordinates that I have. So you'll say that, okay, these are the number of subordinates you have. Since you are my subordinate, these would also be my subordinates. Plus, you also are my subordinate, right? So the ch over here, you can call it sub, right? Because we are talking of subordinate. So this particular node is also a subordinate. So you'll add 1 for it. Cool. At the end, you'll return the result, or you'll return basically the value that you have populated over here to your parent value. I hope this makes sense. Any doubts in this? The next question is a bit hard. It uses the concepts of trees and DP and a lot of stuff. So just wanted to make sure that at least this question is fairly simple to you all guys and you all understood this in entirety. Any doubts in this? If
So
not,
this
then
one is simple DFS with just storing into the array.
yep, true. So can you, okay, so I already zoomed that. Yeah, this is a simple question. Just wanted to start with the very basic question so that everyone is on the same page. So if you guys understood this question well, then let's move ahead to the next question. That is a bit interesting question, right? So let's move to that. So we'll be moving to tree matching. Cool. So let's understand this question. I think this is the same question. Yeah, over here. So the problem states that you are given a tree consisting of n nodes. A matching is a set of edges where each node is an endpoint of at most one edge, right? What is the maximum number of edges in a matching? Now, what do they actually mean by that? So let me open this. Okay. So let's say this is a node, right? Let me just draw a random tree for that matter. So don't confuse a tree with a binary tree. A tree can be anything, right? It just needs to be a graph without edges, and it needs to be connected. Oh, sorry, a graph without cycles, and it needs to be connected. Cool. So this is a tree, right? Now I need to find the maximum matching, and the matching is defined as that. Let's say if I pick a particular edge, right? So let's say I pick this particular edge, right? That would mean that this node and this node is consumed. So any edge that is now connected with these two nodes cannot be included in my final answer. So if I include this, right, then I cannot include this or this or this, because these edges have actually a edge with the a side with this particular node. So this can't be used. For example, if I utilize this particular node, right, let's erase that. Okay, so if I utilize this particular node, then in that case this and this sorry, this particular edge, if was utilized, then in that case these two nodes would also be utilized, right? So I couldn't use this or this or this. So all these edges couldn't be used further, right? So in this way, for example, if I selected this, then the next node next edge I could have selected this, right? So this is having a matching too, right? In this way there could be a number of matchings you can have, right? So you need to tell the system that what is the maximum number of matching you can obtain. Any doubts in the question, or the question is clear? Cool, I'll be moving ahead then if the question is clear. So how would we solve it? Let's try to break the problem into smaller sub problems, right? So what I'll say is, let's root my tree at any node. So this is not a rooted tree, but I can root it at any node and it won't change anything, right? Now we generally say that it's without loss of generality, but the thing is that, okay, let me, yeah. So even if you're rooting a node at, let's say, 1 or a 2 or any node for that matter, if I'm breaking down it to sub problems, right, the generality generally holds, because the sub problems are independent of each other, and because of that, no matter what node you select as the root node, the answer always remains the same. Cool. So with that, let's say this is my root node, right, and these are the connections it has. Cool. Let's say these are for the more corrections these node have. Okay, now what are the two cases that can happen over here? So this is my root node, right? So I can say that the only two cases are that either I select a particular edge that's coming out from it, or which is connected to it. Now these are the three edges that are connected to it, right? Okay, yeah, these are the three edges that are connected to it. Either I select one of them, or one of the cases that I can neglect all of them. So but I cannot select two of them, right? So either I select one of them or I neglect all of them. Cool. So let's say, firstly, let's assume that I'm neglecting all of them. So I'm not considering this edge. Okay, give me a second. Yeah, I'm not considering this edge or this edge or this edge, right? Since I'm not considering these edges, so these become independent problems now. Now this particular tree or this particular subtree can be called a independent subtree itself, right? And this would also become an independent subtree. This would also become an independent subtree. Cool. I'll just ask for the values. So whatever my algorithm is, let's discuss the algorithm later, but I'll just ask for the value. So let's call this name as maybe P. This is, okay, let's call this maybe X, right? This is X, this is Y, this is Z. So my R would ask X that, okay, return me the answer that what is the maximum matching you can have. Now X doesn't knows about this entire remaining tree. Okay, give me a second. Okay, this entire remaining tree is not known to X. X just knows about its subtree. Considering that X is the root node, X would just know about its subtree. So X can also do some sort of computation, right? So as to calculate that what is the maximum matching it can obtain. So it will return it this. So let's say the value it returns is A. Cool. Similarly, it will ask Y, it will return it B, and it will ask Z. It is going to return C. Cool. Now R would say that one of the answers could be A plus B plus C. This is always gonna be valid because there's no connection like this over here, right? Because it's a tree and a tree doesn't have a cycle. So these subtrees are not connected. These are actually independent. So if it is returning a value A, that value is not dependent on B. That value is not dependent on C, right? So a plus b plus c is definitely one of the solutions. But wait, I only considered this scenario when you are not taking any edge, right? So you are not taking these three edges. Then only this was your answer. What if you take one of the edges? So let's say I want to consider this particular edge. So this is the edge I want to consider now. Okay, give me a second. Yeah. So this is the edge that I want to consider. As soon as I consider this particular edge, that would be valid because I'm not considering these two edges. So this and this edge is not being considered. However, as I consider this edge, then any edge that was connected to x cannot be considered further, right? So that would change the answer because it was possible that when x returned you a, right? So when x returned you a, it assumed in the answer a itself one of these edges. Nancy, can you mute your mic? Cool. Guys, just mute your mic if you don't have a doubt. If you have a doubt, speak up. Cool. Over here, so what I was saying is that when x returned you answer a, it is possible that x assumed that one of these edges was being consumed. But now since R wants that it will consider this particular edge, so it's not possible for x to use this edges. So would we
सर
recompute
यार
the...
नॉट ऑडिबल सर सुनाई नहीं दे रहा है
Bro, am I audible?
सर
Guys,
किसी का
Yes,
माइक
yeah,
नहीं
yeah.
है
bro, your connection is who's speaking? Ketan. Ketan, probably there's some problem in your connection. Guys, could someone else confirm that I'm audible?
Yes, you are audible.
Ketan, can you rejoin the meet?
ओके ओके सर
Cool. Cool. So what I was saying over here is that since these edges were included, let's say in A, so A is definitely not the value I can tell to R, right? So what should I do? Should I recompute the entire thing? That actually would be a waste of time, right? And that would increase the time complexity. And just to tell you, it would become n square. That is something we cannot afford because over here the n is going up from 10 up to 10 to power 5. So either we need an order of n or an order of n log n complexity, right? But one thing we can do is that whenever we are standing on a node and we are calling it the root node, right? For example, when we are standing on the x, we are calling it a root node. We can ask our function to return us two values. One of the values would be considering that none of these edges are being considered, right? So that would be the value a, and let's call the other value a naught, right? So a naught would be the value if any of your edges is being considered, right? So basically a means that I'm returning you the value and none of these values are being considered, or let's call it a naught. Give me a second, that's becoming a bit messy. Okay, let's call these two values a naught and a1. So a naught basically means that none of these edges are being considered, right? That are going directly out or which are directly connected to the root node are not being considered. Then we call it a naught. If some of your edges are being considered, let's call it a1 itself. That's pretty cool, right? So that is something we can do, and that won't change the complexity a lot. So that is something we can do, right? So as soon as we pass these values, so the tree actually would become, let me redraw that. That actually got a lot messy. Okay, there was some tree that I was having below this. I'm not really concerned about that. But now to my parent R or to my root R, the values that would be returned would be a naught a1, right? This would be b naught b1, and this would be c naught c1. So my parent would say, or R would say that, okay, a1 plus b1 plus c1 is definitely one of the answers which I have, but this is considering that I'm not consuming any of these nodes, right? What if I consume some of these nodes? So as soon as I let's say I consume this node, then the answer would be a naught plus b1 plus c1, right? If I consume this node, then my answer would be a1 plus b naught plus c1, right? If I consume this node, then my answer should be a1 plus b1 plus c naught, right? And this can extend, so your node can have n number of children, and this idea would actually extend. Any doubts so far? This was the heart of the algorithm. If this is clear, then everything should be fine. Any doubts? Cool. I'm moving ahead. You can stop me right away if you have a doubt. Cool. So that's what we're gonna do. Let's try to open the submission itself. the code is pretty understandable. So I'll be like walking you through the code itself. Okay, this is the code. What we are doing is that firstly we'll be calling the same method. So I'm calling it DFS, but the point over here is we are returning two values, right? Pair of intent. Now what does this mean? Let's discuss that later. So then when I'll be calling it for a node root, and we'll be considering that particular node as root, right? And we'll also be passing the graph or the adjacency list, you can call it, right? That's the standard way of doing a DFS call. Along with that, we also call the parent, so that the child, if the child and the parent are similar, then that means you are trying to get into a loop itself, and you don't use that. Then what I'll say is that okay, so you are expecting a value from your children. So standing at, okay, give me a second. Yep. Okay, so over here, standing at R, you were expecting two values from X, right? So X is one of your children, and you were expecting two values from it. So you want to store it somewhere, so you'll be storing it in a pair. So this is actually pair of intent. I use auto a lot. You can use whatever you want. Cool. So this is actually a pair of intent, and it would store the values. So basically it has two values. One would be that if you are considering some edges outgoing from that particular node, and the other would be that you're not considering any edges outgoing from the particular node. So it says that you want to add the value. So initially you want to add the maximum of these two, right? So if you're considering that you're not going to consider, so if you feel that you're not going to consider any of these edges, right? This or this edges, then you can say that you can return that I can choose the maximum of A0 A1, B0 B1, C0 C1, right? I'm not even concerned about it. So that is cool that I can do. So I'll be saying that my sum is I'll increase my sum by the maximum of these two. Then I'll say that if I do consider the edge, right? So if I consider that you or that X actually is considering one of these edges, then what is the then what is the value I get? So I'll store that. So v dot first, or the first element over here, is containing that value, right? And the second is subroot without edges. So if I consider that your subroot or your or X over here is not considering any of these edges, then what's the value? That would be stored in v dot second. I'll store that in this particular vector. Now why I'm doing all of this would make sense, because now I want to check that what would happen if I'm using this particular edge, right? So as soon as you use this particular edge, then I need to say that I cannot use your value, which is corresponding to the fact that you are also using the edge in your neighborhood or in your child's, right? Or your children. Okay. So if that happens, so I'll have to check for all my children. So I'll say that, okay, children 1 or children 0, I want to utilize my edge with you. So you tell me what's the answer if you don't consider your edge with your children, right? So he'll say that the answer would be 1 plus sum would be there, right? From sum I'll have to subtract something. So I'll subtract some subroots without edges. Cool. And I'll add subroot with edges in that. And after doing all of that stuff, I'll just store the value in root, right? And I'll return it. That makes sense, I hope. Any doubts over here? Or things went a bit over the head? Guys, any doubts?
Sir, over that.
Over the head? कौन बोला भाई बार?
सर मैंने
अच्छा, अभी भाई क्या समझ नहीं आया बता.
ये कोड समझ ही नहीं आया कोड.
अच्छा ठीक है, इसको आराम से एक बार ड्राई रन करते हैं, ठीक है? कूल. Let me start
Okay.
dry running it. Cool. So we'll be using the DFS. So let's firstly just draw the tree that they had provided us. Let's draw that tree. Okay, tree matching. Okay, so from 1 we are going to 2, 1 we are also going to 3, right? From 3 we are going to 4, and from 3 we are going to 5. Good. इसको देख. Now standing at 1 we'll be going to 2. Cool. Now we'll ask that to return us two values. Now what are the two values you want 2 to return? So 2 should return you two values. One would be that if it has any sort of children, right? And now 2 wants to consider any children, then what would be the value? And if it doesn't, if it wants to consider the edge with any of its children, then what would be the value? If it doesn't want to consider any of the edge with its children, then what would be the value? So now two cases are there. So 2 would basically say that I don't have any children, right? So either way my answer is going to be 0 0. It cannot contribute anything, so it will say 0 0 is going to 1. Cool enough. Now you ask the same question to 3. The 3, okay, tell me that what are the values that you're gonna return me if you consider one of the edges to your children, and if you don't consider one of the edges to your children. Cool. Or if you don't consider any edges, not one but any edges to your children. So 3 would say that okay, I have 2 children. Now if I don't consider any of the edges, right, in that case my answer would be 0, because even my children don't have edges further. In case it had edges further, then there could have been a scenario that, or there would have been a scenario where I could have returned you some values. But in case I'm not considering any values coming from my children, in that case I'll have to return you 0. But if I consider some values that I can utilize one of these edges, right, then I'm going to return you 1. Make sense? Guys, make sense so far?
Yes, sir.
Okay, cool. So these are the two values that I'm gonna get. So one would say that okay, I got two values. One got a value 0 0 from its left children or from the children 2, right? And it got a value 0 1, right, from its children that was 3. Now it says that considering the maximum of these values, so it can say that okay, I'm gonna consider that 3 is saying that I can give you a value 1, right? 2 is saying that I can't give you a value, so my result is already 1. So 1 is something I can always have. So one edge one matching I can always get, right? Can I do better than that? So it's gonna say that okay, to what would happen if I consider this particular edge? So this particular edge, if I consider, then what would happen? So 2 would say because you are considering this particular edge, I cannot consider any edge to my children, right? But anyway, I didn't even have a children, so that doesn't make any difference. So you can utilize this edge and it won't change anything. So it's gonna look at this particular value, or sorry, not this one but the other one. So yeah, this would look at this particular value, that was if no children of 2 are being considered. Cool. Now if that's the case, it will say that okay, I'm not considering that you I'm not considering that you are putting any edge that is directly linked to you, but I'll be considering this edge. So what's my answer? So we'll say 1 minus, what do I need to subtract? I need to subtract this value, right? I need to add this value, this was also 0, and then what the initial sum I was having, right? So initial sum was 1 itself, so 2 becomes the answer from here. Cool. Now let's do it with 3, that would make it more clear. So it will ask 3, 1 would ask 3 that what if I consider this particular edge, what would be the answer I'll be getting? So 3 would say that okay, if you consider this particular edge, then I cannot consider these 2 edges, right? If I'm not able to consider these 2 edges, in that case you'll have to consider my score as 0, that I already told you. So one's gonna say okay, cool enough. So what would be my answer now is, you're gonna consider one edge that you put right now. So 1 is this one, right? Then you're gonna subtract this particular value, because this is the value you were getting if you are allowing 3 to have a edge to its children, or to count the edge to its children at one of the matchings. So you're gonna subtract 1, you're gonna add this particular thing, because this is now what you're getting, right? And then you're gonna add the initial score you had. So by using this you get a value 2. Oh sorry, you get a value 1 itself. Cool. In this particular case you got a value 2, in this particular case you got a value 1, so you return 2. This makes sense?
Yes, sir.
Okay, so if we go by the code, so the code is exactly doing the same thing. So it's taking 2 subarrays, right? So it's saying okay, give me a second. Actually I've named them wrong, but it's exactly forming the same thing, so just take it with a pinch of salt. Actually the nomenclature has been inverted, right? So what I'm asking is that okay, my subtree, so I have a child, right? I'm gonna ask it that return me the 2 values that I just explained. So it's gonna return me the 2 values. I'm gonna say in my sum I can add the maximum of these two, right? So my sum initially contains, so sum basically means that if I consider the individual subtrees, what is the best answer can I have, right? So whatever best value they're returning, I can add that to my subtree. Because okay, over here, I could have easily considered that I'll take the best value from this subtree and the best value of this subtree, and I'll add them up. Or if there were, let's say, 3 subtrees or 4 subtrees, I'll take the individual best values from each subtrees and I'll add them up. Cool. So that's what I'm doing over here. Then I'll say subroots with the edges, I'll push that value. Subroots without edges, I'll push this value. After that, I'll make a presum. Okay, this wasn't required. This was an extra headache I took. Anyway, cool. So after that, I need an answer now, right? Now what should be my answer? So my sum is obviously defined that if I'm not considering the current edges, then what would be the answer? That is already defined. That is this one. So if I'm not considering any edges, what is the value I'm getting? That is sum. But what if I want to consider one of my edge? What would be the answer then? So the answer simply would be 1 plus, the 1 I'm adding because I'm considering the current edge, right? Plus sum. Now I'll have to subtract. Now I'll subtract the value. Okay, so over here, 3's case for more pertinent. So you had to subtract this value 1 from here, right? Now the reason you subtracted this value is because you were getting this value only when you were allowing 3 to have a edge or to count the edge to its children as a matching pair. Now you're not allowing, so you're gonna subtract it. You're gonna add this value. This is the value that 3 gives you when you don't allow it to have a matching pair in its adjacent edges, right? Then you say that answer is going to be either the value already have or this particular value. This is what you're gonna do. This makes it more understandable. Guys, any doubts in this? Or wherever you have a doubt, you can point me to that. Cool.
Says also share the answer on the chat so that we can
Abhi, your voice is
practice. We
breaking.
will know.
Can you type it over here? Okay. Till the time Abhi is typing his doubt, the only thing that actually remains are pretty simple. So then I'm gonna store this in my DP root. You can actually get rid of that. Even then, the things actually won't change. You can actually get rid of this DP root if you want. You can rather just return it right away, right? Okay, and over here then you'll have to print the value that is being returned to you in this, or you can say auto it is this and then it second. So even this would give you the same answer. Okay, I assigned it. Let's remove that. Cool. So this would also give you the same answer. No changes, complexities also. Let's look at his doubt. Share the code also. Yeah, sure. I'll do one thing. I'll share this link. I hope this link is like clickable by you all and this is viewable. Okay. In case it's not, let me make it a bit simpler.
सर यू कैन शेयर द कोड नीचे रहता है लिंक नीचे रहता है
कहाँ पे नीचे हो?
थोड़ा ऊपर
अच्छा,
शेयर कोड टू
got it. So yeah, this is the code. You can go through it, and I really expect you guys to at least solve these two problems, right? Because DP on trees is something that is a bit harder to visualize per se. If you go to the like try these problems on your own, definitely your concepts are gonna be much better. And also as we proceed further, so the problems are gonna become much tougher. Now, I am almost certain that you guys are finding it tough to comprehend and to study, but only understanding and studying tough things are gonna make you grow, right? I can easily teach you 2 pointers or some very simple grid sorting algorithms, but then those things are not gonna help you much considering the levels you are already at. So I'll really suggest you guys to go through these problems, and before our next session, try to at least try this problem on your own, the tree diameter problem. This is actually a good problem and it was asked a lot of times in the placement exams also. Now I gave the placement exam for several companies, maybe like 50 companies or so, and it was asked a few times at least. This is a good problem. If you're not able to do it, it's fine enough. I'm gonna explain it then in the next session. So in the next session, I'll be targeting these two problems: tree diameter and tree distance is 1. But you at least try these two problems, and if you have any doubts, then you can ping them in the CP Doubts channel, and I'll try to help you with that. Cool, guys. So that's it for this session. I hope you understood and enjoyed this session, and you learned at least something. If not everything was clear, at least you learned something. And for any doubts, you can ping me. Cool, guys. Bye bye. Thank you.